Okie dokie. Hello, everyone, and welcome to a night of meteorological marvels like you've never experienced before. We're thrilled to present you with the first ever AMS Weatherband Trivia Night, where we'll be venturing deep into the heart of tropical cyclones, forecasting, and extreme weather. Tonight's event promises to be both informative and fun as we explore the fascinating world of weather phenomena. Using the Mentimeter app integrated into Zoom platform, we'll be posing questions that will challenge your knowledge, spark your curiosity, and keep you on the edge of your seats. But that's not all. We've got a little extra something up our sleeves. Alongside each question, we'll be serving up nuggets of intriguing information, providing you with a deeper understanding of the awe-inspiring forces of nature. Also, if you have any questions for Melissa and or our facilitators, please use the Q&A option at the bottom of your Zoom screen. So, whether you're a seasoned weather nerd or just curious about the mysteries of hurricanes, history, and extreme weather, you're in for a treat tonight. So get ready to test your wits, learn something new, and have a blast while doing it. Without further ado, let's start this mental meteorological melee. And Melissa, the floor is yours.
Thank you, Gideon, for that amazing introduction. Welcome, everyone, to our inaugural Weather Trivia Night. This is going to be kind of a little learning lesson. We've been practicing this, and it should go out without a hitch. If you love trivia in a bar, this is pretty much kind of similar to what we're going to be doing. We're going to be asking questions. You're going to have multiple choice answers. You're going to be timed. So if you get a correct answer, the faster you get it, the more points that you get. There will be a leaderboard that will show who is in the lead, who is the fastest, and who's catching up. And the information on where you actually stand in the rankings will appear on your screen to kind of let you know how close you are to be cracking, the top three. So we do have prizes for our top three contestants, and we'll talk a little bit about later after we award them. But never fear, when we did this as a practice run, a couple people had a couple questions wrong, but still came back to actually win. So as you can see from the welcome screen here, you should have received a participation invitation from Mentimeter. If you didn't see it, you may want to move your Zoom camera or your Zoom screen around a little bit to see if you've got that little invitation, and go ahead and click yes. You can also use a mobile phone. You can use a web browser, an iPad if you don't want to join through Zoom. And as we noted in our reminder, we're going to need you to use a username so that way we can keep track of, who our top three contestants are. Luckily, I don't have to calculate the points. It's going to be calculated for me. So as we're waiting for additional people to come in, the first thing I'm going to have everybody do is tell us where you're coming from tonight. So as I advance the screen, your screen should change, and it's going to ask you, where are you joining us from this evening? If you're joining us from inside the US, all we just ask is for you to type in your response of the state that you're coming from. If you're outside of the US, please let us know what country you're participating from tonight. It'd be kind of interesting just to kind of see where everybody is coming in from. I love seeing these answers already. We've got a lot of people from North Carolina apparently on. So the larger that name, the more people we actually have participating from that area. We also have some people from Colorado, Michigan, Montreal, Washington, D.C., India. So just keep those coming. We're going to give it a couple more minutes. And what this actually does is gives everybody kind of a chance to get familiar with using that Mentimeter. Again, if you did not get the invitation when you logged in to the Zoom or as you came in, move your screen around to see if you can find it. It's going to say that I've invited you to be in Mentimeter. If you did not get that invitation, again, you can use your phone just by entering that code that's at the top of the screen at menti.com. And then that 8-digit code will also allow you access into the Mentimeter. Some people found it easier to use their phone and keep their eyes on the screen, and some people found using that interactive portal a lot easier. So let's see, how many participants do we have and how many people have actually told us where they're from? So we've got about 21 people signed up. I got about 16 participants. So I'm just going to see if we got a couple more people coming in before we get started. We have three categories we're going to be talking about tonight. We're going to be talking about the science of tropical cyclones, forecasting and terminology, and we're going to be talking about some historical tropical cyclones along with those extremes. Again, as Gideon said, if you have any questions as we're going through, whether it is you may have a little Mentimeter issue, or if you have a question about the content that's being presented, please feel free to put it into the Q&A box. We have people that are monitoring the Q&A box. I'm going to keep my eye on it over here as well. And we're going to try and answer all of your questions, as we go along. So we got 18 responses and we have 21 participants. Give it one more little minute before we get started. One of the things I do want to remind people is as we're going through and we're talking, your window may, and I'm going to say time out, and that's just because it's become inactive. So I'm going to give a chance for you to click on your screen before I ask the question. That way everybody has the correct chance or the chance to be able to click on that correct response or their answer for the trivia to find out whether they've got the correct response. One more thing. Once you've selected your answer, you cannot change it. It is submitted. So you may want to think pretty good before you put it in. But again, faster correct answers get more points. With that, I am going to go ahead and get started.
Melissa?
So, yes.
Melissa, I just wanted to jump in and everyone who is on this should be logged into Mentimeter. If you are not yet logged in, please let us know. You can't do this trivia without being in Mentimeter. So if you have not yet been able to locate the invite, either go into Q&A or chat and let us know, and we will try to troubleshoot.
Thank you very much. Again, if you did not get the Mentimeter invite via Zoom, you can join on a mobile device or even a web browser by going to menti.com and using the 8-digit code that is on top of the screen. All right, we're just going to make sure we're good. Yes. Okay. So one of the questions I came across is it hasn't asked for my username yet, and that is correct. You have not been prompted to enter your username. And when I advance to the slide that we are going to start with the trivia, it is going to ask you to put in your username. So I know that is a question that we have received. I know Erica is also fielding a couple of questions right now just to make sure we can get everybody in. All right, I think we are good to go. I am going to go ahead and advance the slides so that we can get to the point where everybody is going to enter in their username. So again, I mentioned we have 3 different topics that we are going to be talking about. The first one is going to be the science of tropical cyclones. This is probably one of the little bit harder categories, and we're going to start early with it. And this is going to be talking really about the meteorological elements that need to come together in order for tropical cyclones to strengthen, to form, and, just some general knowledge about them as well. So I'm going to advance it to the next slide. And as I advance it to the next slide, this is going to be the point where it should be prompting you to enter in your username. So all of our players seem to have been able to enter based on my participants list and how many players we have ready. So again, this is the part where you're going to enter in your username. Make sure that it's something that we can tie back to you. One of the suggestions that was made was use that first part of your email address. Not the full email address, just that first part, or something else that we can definitely tie back to. We want whoever gets first, second, and third place to be able to take home their prizes. Once you guys have gotten in and you have your username available, if you guys can hit the little like button, the thumbs up button, or something like that, that way I have an idea that everybody seems like they're ready to go. All right, looks like we have most of our players in. I've got multiple participants and I got multiple players. We're going to go ahead and get started. So again, when I prompt this, there's going to be a quick little countdown. Fastest answers are going to get the most points. And then we'll do a little bit of an education about that particular answer. And then we are going to go ahead and find out who answered correctly and the fastest. So I'm going to read the question and the answer. So remember, fast answers get the most points. What factor necessary to tropical cyclone development is very weak within 5 degrees of the equator, so that storms rarely form here? Is it Coriolis force, gravity, shear, or the trade winds? 2, 1. All right. 14 of you got it right. It is indeed the Coriolis force. So if we take a look at the structure of winds and our circulations across the globe, here you go. You can see the different jets and the cells. That area around the equator, we usually have the Coriolis force has a horizontal component that is too small to actually give it that turning that it needs for that circulation to form. So very rarely do you actually see any type of tropical systems that form within about 5 degrees of the equator. Now, there have been some rare occurrences where that has happened, but on an average or a climatological, without that Coriolis force there, you're not going to be able to form storms. Of course, Coriolis force is also what gives us the spin around our low pressure systems, our counterclockwise spin around low pressure systems in northern hemisphere and clockwise around our southern hemisphere. All right, so let's go to our leaderboard and actually see who got it right and the fastest. Wow, some of you guys are really close. This might actually be a tighter game than I initially anticipated. All right, so there you are. Now you can kind of see where you're at. This is going to be a pretty close game based on how you guys answered that first question. So let's go ahead and we're going to move on to our second question. Again, going to make sure everybody has their screen. So click on your screen, make sure you're still active. So that way when you do click on your answer, you don't have to double click on it and potentially miss those points. All right, here we go. We're going to start the next question. What term describes the special balance of forces that occurs in the strong winds near the center of a hurricane? Is it hydrostatic balance, gradient balance, geostrophic balance, or cyclostrophic balance? Ooh, 6 of you got it right. It is cyclostrophic balance. So let's talk a little bit about cyclostrophic balance. This is actually this slide here is going to have a graphic that I pulled out of some old notes. And what it is you can kind of see around a low pressure system, you've got that balance resulting between the centrifugal force and the pressure gradient force. And this is like assuming that you have like negligible like Coriolis force effect on there. So, you know, this is what actually helps with that spinning that we actually see around the center of the circulation. All right, let's see who got the 6 people who got this one right. All right. Now, for those of you who didn't get it right, remember, you can always stage a comeback. We've seen it happen before in our dry run that we did the other day. All right, so here's our third question again. Make sure that your screen is active. Make sure everybody's in. All right, here we go. Faster points, or faster gets more points. What's the process inside a tropical cyclone that maintains the storm's strength and its circulation through the vertical column of the cyclone? Is it angular momentum transfer, latent heat release, subsidence in the eye, or radiative cooling? And 12 of you got it right. It is latent heat release. So here's it's a schematic. Let me pull it up of what you actually see when you are kind of looking at that formation of the tropical cyclone. So you have moisture and that from the ocean, and you have also that heat content too. And so the winds, as they're coming together inside the storm, are bringing those 2 components together, which are 2 of the primary sources of energy for any type of tropical cyclone development. So as that rising air expands and cools and the thunderstorms and the clouds start to develop, there's also a latent heat release within that particular system. So you get this warm core, as we've heard it called, formation of it within the inner eye wall. That's why they call it that warm core of the storm. And through that release of the latent heat, that's basically what helps fuel that energy for the storm to form. All right, let's see. See how quickly those tables can turn? So again, if you are not showing up on the top of our leaderboard, don't give up hope. We still have plenty of questions left to go. All right, let's move on to our fourth question. That's going to be in our science of tropical cyclones. Which factor or factors will cause asymmetry in the tropical cyclone's eye wall, leading to uneven cloud cover and precipitation? Is it movement through the surrounding atmosphere, the formation of tornadoes, wind shear, A and B, or A and C? And 7 of you got it right. So it is actually when you're moving through the surrounding atmosphere, but a large part of that is going to be based on the wind shear. So I'm going to pull up this diagram that kind of talks about what that wind shear actually does. So when a hurricane eye wall has an environmental wind shear, a very strong environmental wind shear, you kind of see that displacement of the heaviest rain band that is around the center of the eye wall. And as you can see in the diagram, you get the primary downdrafts, but you also kind of get that exhaust anvil that pulls off of the top. And when you get that displacement, you'll have the precipitation and the cloud cover kind of be not symmetrical around the eye. And most people, when you think about wind shear, you really think of that's going to tear apart the storm, but that's not always the case. You can have a high shear environment, but still not lose any strength in your storm. All right, so let's see who got it right. And Kyle is in the lead right now. All right, so this is going to be our last question in our Science of Tropical Cyclones category. Again, make sure you're clicked on your screen so that it is active and you're ready to go with answering the question. All right, which of the following is an example of the Fujiwara effect? Is it intensifying during extratropical transition, 2 tropical systems rotating around each other, weakening over cold water, or stored surge amplification? All right, 15 of you got it right. It is when typically you see 2 tropical systems that are rotating about each other. One of the other things that can happen with this particular effect is that if there is a smaller, weaker circulation, it will typically orbit the larger circulation before it becomes completely absorbed. But if the 2 circulations are about the same strength, they will orbit around each other and then go off on their different paths. This is typically seen in the Pacific. This is something that you typically see in the Pacific Ocean happening, not so much in the Atlantic. It has occurred in the Atlantic. And this is actually an example of 2 typhoons in October of 2009 that actually went through this particular effect of rotating around each other. All right, so as we end our first category, let us take a look at our leaderboards. Okay, so here we are. We've got 10 more questions left to go. It is still anybody's game. So the next section that we're going to talk about is going to be talking about forecasting and terminology. So this is a really quick peek inside the National Hurricane Center. If no one's actually had the privilege to go down there and visit, it is a really interesting place. It's co-located with the National Weather Service in Miami. And the wall that they have there still exists where they track hurricanes in a very similar fashion to the way they used to do. All right, so make sure you tap on your screen again. Get active, and let's move on to our next question. What product is issued when tropical storm conditions are possible in an area within 48 hours? Is it a tropical storm advisory, a tropical storm watch, or a tropical storm warning? Everyone has voted, and 14 of you are right. It is a tropical storm watch. So I'd like to thank the National Weather Service in Mobile for this graphic. It kind of really breaks it down. So a watch is going to be when conditions are possible. Warning is going to be when you have those particular conditions that are expected. So I know everyone has kind of seen the taco watch, taco warning, or cupcake watch, cupcake warning graphics. A watch is basically stay alert and be prepared to take action if necessary. And a warning means that you need to take immediate action to protect life and property. So just remember, watch, it's possible. We have all those ingredients together to make that cupcake, but we don't have a cupcake yet. Warning, we've got that cupcake. All right, let's see who was the fastest on that one. It looks like Casper was the fastest on that one. Oh no, Lewis was. Again, this is still anybody's game. All right. Question number 7. This is going to be the second one within forecasting and terminology. Make sure you click on your screen so that you are active to answer the question. All right. Roughly, how often is the center of a tropical cyclone's path within the forecast cone? Is it 45% of the time, 55% of the time, 65% of the time, or 75% of the time? 3, 2, 1. All right, 8 of you got it right. It's actually 65 or 66% of the time that the tropical cyclone's path will actually be within the cone. What that actually means, 33% of the time, that center of circulation will be outside or track outside of the cone. Now, most people think the cone is all of the different models thrown together to create that cone. But what it actually is it's formed with connecting circles on the forecast points and then the 5-year historical track error that the National Hurricane Center has. So again, just a reminder, when we're looking at the forecast cone, it's only going to display information on the potential track and the uncertainty of that track, and nothing about the specific impacts of the storm. Most hurricanes and tropical cyclones can be up to 300 miles wide. So depending on where they hit, you may be far removed, but still be able to feel those impacts. All right, let's see who got it right the fastest this time. And Louis J. squeaks out to the lead. All right, our third question in forecasting and terminology. Again, make sure you guys are ready to answer the question. I'm going to go ahead and prompt it to get started. In the past decade, what percentage of direct tropical cyclone deaths in the U.S. were caused by freshwater flooding from heavy rain? Was it less than 20%, 20 to 50%, 50 to 70%, or greater than 70%? Everyone has voted, and 7 of you got it right. So if we're going to just take a quick look at the stats, and we'll break it down from what we actually have. So data from 1963 to about 2012, 49% of the direct fatalities from tropical cyclones actually came from storm surge, and 20% or 27% was from freshwater flooding. But if we look from about 2013 to just last year, 2022, it has changed. And now 57% of the direct fatalities from tropical cyclones are actually coming from freshwater flooding. And the percentage from storm surge has actually decreased to 11%. So let's see. We still are seeing some movement in our leaderboard. So again, guys, don't give up. All right. Fourth question for forecasting and terminology. Which of these is a leading indirect cause of death from tropical cyclones? Is it carbon monoxide poisoning, falling trees, fires, or poisonous snake bites? 3, 2, 1. And 12 of you got it right. It is carbon monoxide poisoning. However, it's not the actual leading cause. When we take down all of and break down the indirect deaths, traffic accidents is, believe it or not, just edges out the cleanup accidents as being the top indirect. So cleanup accidents are going to be those that actually happen after the storm. When people are using heavy machinery, they're trying to clean up after, fallen trees, buildings that have been destroyed. And carbon monoxide comes in third with 12% of those. But you can also see there are a couple other interesting ones that are in there. Post-storm heat related. So there's actually a lot of instances of heat related illness. And some of that is actually due to the loss of power in some care facilities where, you just don't have that cooling, you don't have that AC to help cool you off after a storm has moved through. And we saw that in Louisiana after some of the more recent storms that we've had there, including Ida. But yeah, you can see there's a bunch of indirects and there's a category of unknown causes. I have no idea what is in those unknown causes as I look through the research, but this is kind of just a breakdown of what those different indirect causes of those fatalities are. All right, let's see. All right, our last question in our topic area for forecasting and terminology. Everybody make sure you're active. All right, here we go. How is rapid intensification defined in a tropical cyclone? Is it that a storm gets one category stronger in 24 hours? Is it a pressure drop of 24 millibars in 24 hours? That the winds increase 35 miles an hour in 24-hour period? Or that it goes through an eye wall replacement cycle? And 8 of you got it right. Most people think it's actually defined by the pressure, but it's actually defined by the wind speed increases. So a good candidate to talk about rapid intensification actually would be Hurricane Maria in September of 2017. So it went from a Category 1 on September 17th to a Category 5 on September 18th. And there are different key ingredients that can help cause that rapid intensification. Of course, high sea surface temperature, low shear, excessive ocean content. But not all of those ingredients need to come together in order for that to happen. And if all of those ingredients do come together, you don't necessarily get every single storm to go through that rapid intensification. It also takes a lot of small scale features that happen within the storm's core to cause that. All right, let's see after Category 2 where our leaderboard actually stands. All right, there we are. There's our standings going into our last section. And then we will open it up to a little bit of Q&A that you guys may have. So now we're going to talk about some of the historical tropical cyclones and some of the extremes that we've measured across, the record that we currently have. Record in the tropical Atlantic is from about 1850 to present. And we're going to kind of briefly touch on maybe some stuff in the Pacific as well. All right, let's get everybody active again. Make sure you click on your screen. There we go. Make sure everybody is in and ready to answer questions. All right. So, in what year did the last known hurricane directly impact California? Was it 1858, 1938, 2023? And 4 of you actually got it right. So I know you're all thinking, wait a minute, didn't we just have something happen and didn't it just impact California? Well, it wasn't a hurricane and it didn't directly impact California. But in 1885, what's known as the San Diego hurricane came very close to making landfall in Southern California. Most of these storms have been that we've been able to find in the past record, in the back in the 1800s, come from ship's logs. They come from fort data. There's an example of one of the meteorological registers from the Fort New San Diego during October of 1858. And so we find all these information, we start going through rebuilding analysis, and a lot of work is done by AOML, which is the Hurricane Research Branch of the National Hurricane Center. They go through and they'll do a lot of this reanalysis to find these particular storms and what potential impacts are. So on that form there, it talks of a great storm causing the air to be filled with dense clouds and dust. Some houses were unroofed and blown down, trees uprooted, and fences destroyed. So this was the only record that we currently have of a hurricane directly impacting the San Diego area. There have been other tropical cyclones that have impacted California. In 1939, the only tropical storm or tropical cyclone on record to make landfall in California during this 20th century happened near San Pedro. In 1976, Kathleen came ashore and it caused 14.76 inches of rain, which is actually the statewide tropical cyclone rainfall record that we have in California. And then in 1997, which happened to be an El Nino year, during the Pacific hurricane season, California was impacted by 4 storms, Guillermo, Ignacio, Linda, and Nora. Doesn't happen often, but when it does, it usually causes a lot of rain in the area. All right, we're going to move on to our next question. And it looks like everybody is ready to go, so I'm going to go ahead and get into it. Which tropical cyclone produced the largest rainfall total in U.S. history? Was it Allison, Camille, Florence, or Harvey? Now we're 3, 2, 1. All right. Most of you got it right. It was definitely Harvey. So what I'm going to do is I'm going to show you guys an analysis that was done by NOAA's Weather Prediction Center on the rainfall from Hurricane Harvey. This is just focused in on the rainfall that happened in Texas. There was additional rainfall that happened outside of Texas. Those contours get pretty thin pretty quick, and the maximum amount of rainfall from Harvey, so this is from the entire storm, 60.58 inches. And of course, Harvey was in 2017. And I've listed kind of on the side of this slide here some of the other impressive tropical cyclone records that exist across states from the rainfall. So Hurricane Easy in 1950 produced over 45 inches of rain in Florida. Danny in 1997 was almost 38 inches in Mississippi. The August hurricane of 1940 produced about 37.5 inches in Louisiana. Most recently, Florence in 2018, it produced almost 36 inches of rain in North Carolina. Here in South Carolina, where I am, we had 24 inches of rain from that particular event, and that one is the statewide record here for tropical rainfall in South Carolina. And then George in 1998, over 32 inches of rain in Alabama. Previously, Allison in 2001 was the record for the state of Texas. It produced just shy of 41 inches in Jefferson County, Texas. So that was actually the record before Harvey happened. All right. Most of you got that right, so let's see who actually got it right the fastest. And it looks like James got it right the fastest. Who? Nope. Oh, Kyle got it right the fastest. All right. Question 13 of 15. So we're getting towards the end here. Got some more history questions for some of these history buffs. What is the name of the only known confirmed hurricane to have formed in the South Atlantic Basin? It happened in 2004. Was it Bonita, Katarina, Denny, or Iba? Three, two, one.
Hey, Melissa, one good question that did come in from Rick. He asked when we were talking about the Fujiwara effect, if they ever merge. And I think you kind of touched on this a little bit, but when the storms are of unequal size and or strength, then yeah, the smaller one does often get absorbed into the bigger one. So that's kind of an interesting fact. And very rarely you'll get something called constructive interference. If you remember that from high school physics or high school science, when you have two waves that interact with each other at the same frequency, then they can basically add each other's amplitude. And sort of the same thing is happening with those tropical storms. If they are able to merge, it's rare, but it can happen where they cause constructive interference and it actually makes the parent storm stronger.
Yes. Thank you so much, Erica, for answering those questions. Have we had any other good questions that have come in from our audience?
The rest has been, technical stuff, just, hopefully everyone's able to get in here. But that was an interesting question that had come up during the trivia. I think that this is going at a pretty rapid pace where we might not have time for it, but now is a great time if you remember any of these questions that, sparked another question in you.
Exactly. So, and it seems like I may have it got back up and running. Erica, can you just let me know, do we have the screen back up?
I see. What is the name of the only known and confirmed hurricane? Yep.
There we go. Okay. So I apologize again, guys. This is kind of new for us. This is the first time we're doing it. We're going to work out some bells and whistles and hopefully when we do this again, It'll be a little bit smoother without as many bumps along the way, but I do appreciate you guys hanging in there with us on this. So I did get to the right slide. So we did have 10 of you that guessed it correctly or knew the answer, and that was Katarina in 2004. So we're just going to take a quick look at that particular storm. This is a beautiful image that was taken from the International Space Station of the storm, which actually formed in March of 2004. It developed from a cold core stationary front that had drifted off of the coast of Brazil, and then had some subtropical storm characteristics, and then actually kind of transitioned to a tropical storm. We kind of recently saw that with what was the storm that just made landfall? Ophelia. And this was actually the first tropical cyclone that made landfall in Brazil since they had reliable records. So this is kind of the one that kind of stands out as being the oddball of them all. All right, let me make sure I can advance the slides correctly. All right, let's see. All right, we're getting down to the last two questions. Again, thank you guys so much for sticking along with us. I'm going to give everybody a couple more seconds to get logged back in since we did have that hiccup with Mentimeter. If you did not get a re-invite code to be part of Mentimeter on the Zoom app, you can go to menti.com on a web browser, your iPad, your phone, and enter in that 8-digit code. And that 8-digit code should get you back into the quiz show. I feel like we may have lost a couple people there. The app didn't reopen, trying in the browser. Okay, Joseph, we got you. Actually, yes, Rick, that is a really good point. The name did call from the landfall location. The storm didn't have a name until it actually made landfall, and it was in the São Catarina area of Brazil is where it made landfall, and that's where they got the name. So that's a really good point. Thank you for that. And Joseph, Vicky, you can just let us in Q&A know if you were able to get it open back up in the web browser. Again, all right, what is the name of the Pacific typhoon that caused serious damage and loss of life on Admiral Bull Halsey's fleet in World War II? Was it Mary, John, Cobra, or Connie? All right, everybody has voted, and 5 of you got it right. Pacific typhoon, it was Typhoon Cobra. The pictures that are going to appear on your screen, if anyone has ever toured an aircraft carrier or been on any of these ships, you know how large they are, how massive they are. So imagine what the winds and the wave action has to be to get the tilt on these particular carriers. So this was part of Task Force 38. That was out in the Pacific at the time. A lot of these ships sustained heavy damage. There were actually 3 destroyers that sank because of the storm: the Hull, the Monogram, and the Spence. Almost 150 aircraft were destroyed, and unfortunately, almost 800 people lost their lives from this particular event that happened. There was different things that were going on at the time, and they were trying to coordinate all of this. And one of the things that actually came out of this unfortunate tragedy with this fleet was the establishment of the Joint Typhoon Warning Center. And so, that they are now basically the entity. They're like the National Hurricane Center of the Pacific. And a lot of that coming together came from this particular event. And interestingly enough, naming conventions in the tropical Atlantic went from like the phonetic alphabet to using names in 1950, but in the Pacific they were actually using names in the 40s to some of the names that I actually had there as options were names of typhoons in the late 1940s that were observed in the Pacific. All right, so let's see where our leaderboard stands now. All right, so we're coming up to our last question. I'm going to give everybody a chance to get back in. Again, remember, hit the screen to make it active. This is going to be the last one for the evening, and then we will definitely open it up to more questions if you guys have any questions about any of the things that we talked about this evening. All right, and here we go. Oops. There we go. Which of the following hurricanes is famous for intensifying during its extratropical transition? Was it Alicia, Andrew, Katrina, or Sandy? And it was Sandy. So we're just going to kind of take a quick look at Sandy. If you can see in the image on the satellite image and the infrared overlay, you can kind of see that red arrow that's actually pointing to an eye wall that is starting to form in Sandy as it was doing this ET transition. And just to kind of show some of the damage, I mean, we've all seen some of the pictures that have come out of New Jersey from Sandy, but that was like a new inlet that was cut in that particular area of New Jersey. Extratropical transition is still a process that forecasters are trying to understand better and be able to forecast better. And with different systems as they decay and as they transition into tropical, extratropical, you see them decay, but you also see some that become more intense. They rapidly intense. They become larger systems. And this is still kind of one of those areas of the study of tropical cyclones that we're still looking into some of this information and trying to get better when it comes to these particular events. All right, so let's go to our leaderboard and find out what our final standings were for the evening. I wish I could do a little drum roll so you could hear me doing it, but it looks like Louis J is our first trivia winner. Thank you guys so much for participating. Casper, you came in second. And then Kyle TWTS, you are our third place winner. And so I'm going to turn it over to Gideon real quick to tell you what you've won. And then we'll just kind of close out a little bit about the trivia and ask, see if you guys have any other questions.
All right. Well, thank you very much, Melissa. And thank you, everybody, for participating in our first ever Weather Band Trivia Night. I am happy to announce that our first place contestant or winner gets a $25 gift card to the AMS Weather Band store. So feel free to take a peek in there and check out the swag that we have available for you. And we'll get that card coming to you right away. I think we're going to figure out a way to get that, get your information so that you do get that reward. Second place gets a $20 gift card and third place gets a $15 gift card. So yeah, thank you for participating. And, we hope that you got a lot out of it besides just the gift cards. Everybody competing had a chance to learn something and had a good time. Melissa, I'll hand it back over to you. Thank you very much.
Thank you. I appreciate that, Gideon. So, I do apologize that there were some bugs in us using the Mentimeter, the Zoom platform. When we did this through the dry run, it seemed to work flawlessly. And, if anyone has ever done anything with technology and these virtual platforms, there's always something that seems to go wrong when you actually do it live. But I do appreciate everyone coming out tonight and participating. It seems like some of the feedback that we've gotten, you guys enjoyed trivia. You had fun. You actually learned something. If you have any thoughts, I believe we'll send out just kind of a little follow-up, a little survey afterwards. So if you have any thoughts, any ideas for additional trivia topics in the future, we're going to play around and see if we can maybe find a better way to make the platform stable the next time around so we don't have problems with scores resetting and getting logged out and logged back into the system. But again, I would like to thank you for participating. And on behalf of our Weather Band committee that put this together, thank you guys so much for attending tonight.
Hey, Melissa, someone wants us to do this again next week.
Oh, I would love to be able to do it again next week. It did take a little bit of time to actually pull it together. But that's again where, our Weather Band committee, is listening to our membership. And we really, if you enjoyed what you guys saw today with the content, being able to participate in something a little bit more interactive, let us know. Let us know topics that you would like to see, kind of researched and content brought forward. Don't think we can do it every week, but we can try and do it like every quarter and try and do something that's, targeted to a specific topic like we did with tropical cyclones this time around. But yes, we really do appreciate you guys being here. And it looks like everybody seemed to have a good time with it, even despite the technological bugs. So again, we really do appreciate it. Mm-hmm. And I'm just going to hang out for a little bit longer just to see if there are any other questions.
Yeah, Melissa, someone wants to know if this is going to be posted as a recording. Claudia or Gideon, do you know?
I do believe that we are still in the discussion phase about that, Erica, because yeah, there's a lot of good content to be had from here, a lot of good information. So uh, we will keep you posted as things develop on that front.
And if
Perhaps,
we don't, go ahead,
sorry, I was
Erica.
just going to say, even if we can't post this, maybe we can put together a little summary and post it on the Weatherband website.
And I would be more than happy to pull together those educational little pieces that we had between the questions and the leaderboard so that you guys can see that information again.
That would be great.
That's awesome.
Great job, Melissa. You had to handle a lot there all at once. That was really well done.
Thank you. I appreciate that. I'm hoping next time we do this, we don't have nearly some of the bugs that we had, but it seems everybody seemed to have a really good time. We'll give it a couple more minutes just to see if anybody has any additional feedback or questions.
Oh, Melissa, I almost missed another question from Rick. He was really bringing it with the great questions. How did they calculate the track error for the forecast cone?
Oh, he's going to put me on the spot with that particular question.
That one I don't know. That's outside of my scope.
It's a little bit outside of my scope too. It was an interesting question. I'll tell you where that question actually came from. I attended a FEMA training on inland hurricane preparedness, and Jamie Rome actually presented material on how they go about doing the forecast cones. And to me, it was interesting to hear. So it's based on the track error that they've had over the past previous seasons. Now, how they calculate the track error, that's not anything I could really talk to. I'm pretty sure if you just kind of maybe even Google hurricane, track error, 5-year track error, you might be able to find some, you might even be able to find some BAMS articles on it, to be honest, within AMS. And then they use that track error based on the timing. So whether it's 24 hours, 48 hours, so on and so forth out, and what their forecast points are. But that entire session that was taught was really interesting, especially learning about the cone, and then just knowing that 66% of the time the track is within that cone, but there's still 33% of the time where the track isn't. I see Kylie has a question in there about how should winners. You should get a email from either the Weatherband committee, and Claudia and Gideon can probably talk to that a little bit more about how they'll be contacted.
Yes, we'll need to be able to get the proper email for the winners. So actually, if we could really quickly just Lewis and Casper and Kyle, if you can contact me, I'm going to put my email on the chat if that's okay, Melissa, and then they can get a hold of me that way so that they can send me their information directly.
Erica, have you seen any other questions that we can maybe answer?
There's one from Caleb here. Do the winds in a tropical storm increase as the pressure decreases in general?
Thank you for catching that, Ted.
Erica, do you want to go ahead and talk about that one?
I mean, in short, yeah, that is a direct correlation, but it's not 100% consistent. You could have storms that have the same low pressure center that have different peak winds at their core. But yeah, it is a very direct correlation. And I think that some of us in the community would like to see the category system, the Saffir-Simpson scale, either get overhauled or get tossed out completely, because there are so many hazards other than wind, and they're not well captured by the Saffir-Simpson scale. You can have storms that are category 1 that bring storm surge that's more typical of a Cat 3. And so people might not be expecting the level of impact from the storm. I know that that's a little bit of a divergence from your original question, Caleb, but I think that it's relevant to this question. But yeah, that's my thinking on it. What about you, Melissa?
Yeah, I mean, there's been so much talk. I mean, the Saffir-Simpson scale, the original Saffir-Simpson scale, actually had storm surge and pressure in it. And then it went through a revamp to just become the Saffir-Simpson wind scale. So, that category is really based on the wind speed and the potential damage that the wind can do, but doesn't really take into account any of the other hazards that are associated with the storm. And I know that that's been a discussion since they actually went and kind of took that original Saffir-Simpson scale and just focused on the wind speed of how do we talk about those other hazards and how those hazards may be the bigger impact than the winds that we would actually see from that too. So, and we are coming up on 8 o'clock. So again, thank you guys so much for those who have hung out, asked questions. We will probably be ending here shortly, but again, we'll be reaching out and, feel free to let us know on the Weatherband forum, about any additional topics for trivia that you may like to see in the future. And we really do appreciate you guys taking your time and participating in this inaugural event.
Fantastic job, Melissa.
Thank you very much.
Well done.
Well done, Melissa. Thank you.
You guys are very welcome. All
Thank
right,
you, Melissa.
everyone.
It was great.
All right, guys, have a great night, and we will be hopefully having another trivia night here in the near future. Everybody take care.
Excellent.
Keep an eye out. Yep. Take care, everybody.
All right.
All right. Have a good evening. Bye.
Bye.
Bye.